Hi Chem, we're starting the last unit today, which is organic chemistry. We're going to start with alkanes. A lot of this unit is learning how to name structures. You'll find out why that's important today and how to name some called alkanes. Also, we'll get into branched alkanes. Okay, so hydrocarbons, they are a type of organic compound with hydrogen and carbon. If they only have single bonds between carbon atoms, they're called alkanes. The simplest alkane has one carbon atom. Remember, carbon has 4 bonding electrons, so it can form 4 bonds. Hydrogen only has the 1 valence. That's methane. Okay, really simple structure. The second simplest alkane has 2 carbons. Okay, and then the remaining bonding electrons bond with hydrogen. So again, both of my carbons have 4 bonds. They're all single bonds. That makes it an alkane. This is called ethane. Okay. There are prefixes that you're going to have to know. Meth means 1 carbon atom. Eth means 2 carbon atoms. Okay. If you have 3 carbon atoms, that is prop. So propane will be the next one. 4 is bute. Butane has 4 carbon atoms. Those will be the ones you'll really have to remember. So methane means 1, ethane means 2, propane has 3, butane has 4 carbons. Okay, so let's draw propane then. 3 carbons, and then the leftover bonding electrons bond with hydrogen. Eventually we'll probably stop writing in the hydrogens because just those lines indicate where they would go. If you want to keep making larger alkanes, you kind of just stretch out the carbons and pop another CH2 in between. Okay, so like butane would look like this. The ones on the end get 3 hydrogens, right? And the ones in the middle only get 2. So that would be butane. Stretched out more, you get an extra CH2. That would be pentane, and so on. I didn't actually write this down, but I can. CH2 is added every time you add a carbon. Okay. That makes CH2 something called a homologous group. I don't know if you will ever see that on a test. I don't think I'm going to ask you about it. Okay, but that's like a chemistry term. So the homologous group for alkanes is CH2 because every time it gets more complicated, you stretch it out, you add a CH2 in the middle. Okay, this is the general formula for alkanes. If you have n numbers of C's, you have 2n plus 2 number of hydrogens. Okay, so for example, if you have 1 C, you got 4 H's. 2 C's, you have 6 H's. Okay, 3 C's, so on. You add 2 H's every time. Start at 4 and then add 2 each time. All right. Alkanes are called saturated. We'll get into unsaturated hydrocarbons later. That just means there's no room to add anything. That's what the word saturated means. Like, if you're walking home in the rain, you might, not like getting wet. But if you're walking home in the rain and you just jumped in a lake, you don't care because you're saturated. The rain doesn't add any water to you. That's how I like to think about saturation. All right, now let's get into naming these guys. It's important because of the existence of structural isomers. Okay, structural isomers. I'm going to show you right now what that means. So I want to start with butane. Butane means 4 carbons. I'll throw all the hydrogens in there. The formula for butane is C4H10. Okay, 4 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. Methyl propane, which you don't know how to draw yet, but that's part of today's lesson. It has a inner structure of carbons arranged like this, and it is saturated, so every carbon has 4 bonds. Put H's at the end of them. Count them up. There's 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. These are structural isomers. Same formula, but they are different compounds. Different structures. That means they have different properties. All right, so we have to name this butane. This is methylpropane. You can't just call it C4H10 because they are different.